Good morning, class. Today's lesson is 1.1, Inductive Reasoning. We're going to take a look at what inductive reasoning is and check out a couple examples. To start with, inductive reasoning is the process of reasoning to a general conclusion through the observations of specific cases. So as we see things happening in the world, we can make predictions about other things that might happen in the world. We make those predictions. We go from specific to general. So as we see specific things happening, we can make general conclusions about those. For example, predicting the population, taking DNA and fingerprints and using them for identification. We've found that individuals each have a separate set of fingerprints or DNA, and we can use that information to identify people, especially in criminal cases. So here are a couple examples of inductive reasoning. We can see here we've got if two odd numbers are multiplied together, will the product always be an odd number? And this example is in your text, goes along with the required reading. You can figure that part out. If you have two odd numbers, will it always be odd? True or false, if the sum of the digits of a number is divisible by 3, then the number is divisible by 3. Again, another example from the text that you were part of your required reading. So if these aren't ones that you're able to quickly and readily visualize, obviously you're going to want to follow along as we go through this. But sum of the digits of a number is divisible by 3, then the number is itself divisible by 3. Third one here, February 28th is a Tuesday, then March 1st is a Wednesday. And we can kind of find that out, again, based on what we see in the world around us. We know how calendars work. We know that the next day of a week after Tuesday is a Wednesday. So that's another way we can use inductive reasoning. Predict the next three numbers in a sequence. This is some of your assignment, is being able to predict these next numbers. So we're going to be looking for patterns and using inductive reasoning to find those patterns. Here we see an example, 1, 4, 9, 16, 25. You probably can figure out pretty quickly that the next step, well, I'll let you figure out what the next step is. Another example here, 1, 1, 2, 3, 5, 8. What is the next step? How do we get to the next three numbers? It appears that we're taking the previous two numbers and adding to it. So when we talk deductive reasoning, this is the process of reasoning to a specific conclusion from a general statement. So this would be where we kind of flip it on its head. We go the other direction. And we use it to prove conjectures true or false. A conjecture is something that we think is happening, and we need to prove whether it's actually happening or not. So this is a flip-flop of the inductive process, where we're going from a general to a very specific, case-by-case basis. So we use these objects in scientific laws, things like the law of gravity, thermodynamics, mathematical theorems. There are a variety of theorems that use this as well. And as we look into this, we are going to do a couple examples of deductive reasoning. So for this example, write a rule for the following table. Here's our table. We have x is 1, y is 5, x is 2, y is 7, x is 3, y is 9, x is 4, y is 11. How do we solve this? Well, we'll look for a pattern of some kind. Try to see if y minus x gives you a simple difference. If that doesn't work, try dividing a number. See if we get x. Write out your work, see what you find. So for many of these, it's going to take that little bit of time to write your work out, do a couple pieces of scratch paper work, figure it out. Take a moment, pause the video, and see if you can write a rule. Hopefully you took a moment. Did you get y equals 2x plus 3? That is a rule that would fit with this example. Other examples, pick a number and multiply the number by 5, add 10 to the number, divide the sum by 5, subtract 1 from the quotient. Make a conjecture about the relationship between the original number and the final number. So again, pause the video if you need. See if you can prove this conjecture. So as we're looking at this conjecture here, first thing, pick a number, Multiply by 5. I use two examples, 7 and 10. So if I take 7 times 5, I get 35. If I took 10 times 5, I get 50. Next, we're going to add 10 to that number. So the 35 plus 10 is 45. The 50 plus 10 is 60. Then we divide that number by 5. 45 divided by 5 is 9. 60 divided by 5 is 12. Lastly, we subtract 1. 9 minus 1 is 8. And over here, 12 minus 1 is 11. So what can we conjecture about the relationship? Well, the final answer will be a number that is 1 larger than the original number. So these are methods and models of inductive and deductive reasoning that you can use, and we're going to explore some of those in the homework for tomorrow. So here's the assignment. It'll be posted on Classroom as well. For this class, you'll be writing out your assignments onto paper, and then I'll be collecting that paper to check over. Classwork's due by the end of class time on the due date. So this is kind of since it's our first lesson, you're going to get a little extra time to work on this one. But generally speaking, you'll receive the video for the next lesson at the mid to end of class time. And then the following class time is when that assignment is due. Remember that if you show no work, you will get no credit where applicable. Some of these are predictions. And so those are obviously when you do your work, when you write out your different predictions, when you try to make it match, please turn in that paper. So everything you do regarding lesson 1-1 should all be on the same piece of paper. I will provide an answer key for you, and that will be on Google Classroom. Please use it to check your work. Please do not just look at the answers and try to work backwards. It kind of defeats the purpose of exercising your mind. So that is it for our assignment for lesson 1-1. And if you have any questions, feel free to ask in class tomorrow.